In this video, we present our paper, Free360. Layered Gaussian Splatting for Unbounded 360-degree View Synthesis from Extremely Sparse and Unposed Views. Given 3 to 4, extremely sparse, unposed images captured in the unbounded scenes. Our goal is to render high-quality novel view in 360 degrees and recover the complete surface of the scene. However, the existing methods fail to fulfill this demand. The sparse view Gaussian splatting requires accurate poses and the point cloud from SFM that are unavailable in the extremely sparse views. Some 3DGS methods use the dense stereo reconstruction model but suffer from noisy geometry in the estimated point cloud and produce many artifacts in rendering. The other methods fine-tune a video diffusion model to generate novel views, but the multi-view inconsistent generations degrades the Gaussian rendering. Therefore, in this task, we want to take as input extremely sparse and unposed images, capturing the unbounded scene in 360 degrees. Then, we build our framework upon the two neural priors where a dense stereo reconstruction model is used to recover poses and the initial point cloud, and a video diffusion model is used to generate more observations for GS. Then, we analyze the challenges in this task. First, the spatial ambiguity in unbounded scenes, where two neighbor pixels has large spatial distances and is hard to distinguish from sparse views. Second, the noisy geometry from the stereo reconstruction model leads to needle-like artifacts and corrupted structure at novel view rendering. Third, multi-view inconsistency from the video diffusion model prevents Gaussian primitives from learning a clear and consistent result. To tackle these challenges, we propose a layered Gaussian-based representation, a reconstruction bootstrap optimization strategy, and an iterative fusion of reconstruction and generation. Specifically, given the sparse input images, we decompose the scene into a front layer and a back layer, and use the dense stereo reconstruction model and bootstrap optimization to get the optimized dense point cloud of the front layer and back layer. Then, we build layered Gaussian representation upon the optimized point clouds and exploit the diffusion model to iteratively take consistent rendering conditions as input and generate novel views to regularize the reconstruction. Please refer to our paper for more details. Next, we show comparisons with existing methods. All compared methods either have foggy geometry or miss the fine structures, such as the handlebar of the bicycle. Instead, our method not only presents a crisp rendering with the complete handlebar but also a detailed surface reconstruction. FSGS and instant splat are distorted by the noisy geometry from stereo reconstruction, and ViewCrafter suffers from the inconsistent generation. Our methods show a consistent rendering and intact geometry of the scene. We further show geometry comparisons with 2DGS. Our methods faithfully recover smoother and cleaner geometry than 2DGS. Furthermore, we show more results. Given only 3 views, our methods can reconstruct various unbounded scenes with consistent rendering and complete geometry. In larger outdoor scenes, our method can use only 4 views to synthesize the accurate novel views and recover the convinced geometry of the scene.